All right. I decided to appear on camera for some reason. Whatever. 2017 number 3. A grocery store purchases melons from two distributors, J and K. Distributor J provides melons from organic farms. The distribution of diameters shows it's approximately normal with a mean of 133 millimeters and standard deviation of 5 millimeters. So for a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137 millimeters? So this is just a straightforward normal model calculation. We have our normal model here is centered at 133 with a standard deviation of 5. And we're looking for the probability that it's 137 or greater. So with all of these normal model questions, essentially, like, you need some way of specifying that it's a normal model and what you're doing. This is the showing your work part, and drawing a picture is by far the easiest way to do that. You could write down a bunch of notation and all that stuff, or just draw the picture and color it in. So we need to find our z-score. Okay, so this distance is 4, our standard deviation is 5, it's 4/5. So what we're going to need to do, normal CDF from 4/5 to whatever. So let's do that. No distributions, normal CDF from 0.8 to 9, and we get 21.19. And that's part A. Distributor K provides melons from non-organic farms. The probability is 0.8413 that a melon selected at random from K will have a diameter greater than 137 meters. For all the melons at the grocery store, 70% are from J, which was our organic one in part A, and 30% are from K, which is the non-organic one with an 84% probability that it's greater than 137 millimeters. For a melon selected at random from the grocery store, what is the probability the melon will have a diameter greater than 137 millimeters? I think the easiest way to think about this is with a tree diagram. For B, we're going to have two branches. This is going to be which distributor did it come from, J and K. J is 70%, and K is 30%. Now, from all of these, we have a greater than 137 plus and 137 minus. The probability that if it's from J, distributor J, the probability that it's greater than 137 is what we answered right there. So that's 0.2119. If it's from B, or if it's from K, sorry, the probability that it's greater than 137 meters is what's told to us in the problem, 0.8413. We could calculate these probabilities if we wanted to, but we don't actually need them because we're only concerned with the overall probability that it's greater than 137 millimeters. Sorry. So to find the probability, 0.7 times 0.2119, which is 0.14833, and 0.3 times 0.8413, which is 0.25239. Add them together, and we get our overall probability that it's greater than 137 millimeters. For part C, given that a melon selected at random has a diameter greater than 137 millimeters, what is the probability that the melon will be from distributor J? Alright, there are a couple of things we can do here. Essentially, it's what's the probability it's from J and greater than 137 out of what's the probability it's 137 millimeters. Which the easy way to do this is just to take the probability of both over the probability of just 137. Which is 0.3702. We could think of this as a two-way table as well if we wanted to. Let's have J and K and 137 plus and 137 minus. And what we want to do is take this is going to be the top and this is going to be the bottom of our fraction. We know this was this, so 0.14833. This was our 0.25239. This was our 0.4007. This would be 1. This is going to be 0.7. This is going to be 0.3. And we could find those if we wanted to, but we don't really need them, and so we don't really care. So there.